Everyone, let's solve problem B from the biweekly contest 125. So I think you have tried this problem for at least 20 to 25 minutes, and then you are coming and watching this video solution. So if you did not try the problem, so please go and try. So if you do that, only then you can improve problem solving skills, or else you will never going to improve. So I hope that you have tried it. Now let's understand the problem. Here, mm, here you are given zero indexed integer array numbers and an integer k In one operations, you will take the two smallest integers x and y in nums. Is telling that I have numbers, and I can take two smallest integers x and y. Suppose consider this 2, 11, 10, 1 and 3, saying that I will take two minimums. I will take 1 and 2, and I will remove from nums. So I have removed it and add minimum of x comma y. That means minimum of 2 comma 1 1 plus 1 into 2. That means 2 plus max is 2 4. So we are adding 4. So my new array will be 11, 10, 3 and 4. So this will be my new array. So we will add anywhere in that array. Note that you can only apply the discrete operations if numbers contains at least two elements. So you can perform these operations if you have at least two elements. And we to return the minimum number of operations needed so that all elements of the array are greater than or equals to k. So we have to perform these operations till my all elements are greater than or equals to k. It's similar to the problem A, but little bit twist. Now, so if you see it and if you think like what exactly we'll do, first I will go and I will take the two minimums. I will iterate and I will take two minimums, and I will say I will use visited array, or yeah, I will use visited array, or you can erase from the vector. It's your choice. So I prefer using visited array, and after keeping visited array, then I will calculate the two minimums and I will make it as visited, and then at this position I will add the new element. Then in the same way, in the second iterations I will go and I will do the same thing again and again. So it will cost me order of n into n. Now if you see, if you want to two small integers x and y in nums, remember thumb rule, guys. If you want the minimum smallest elements, then you should go with the priority queue. Priority queue is something when you iterate at every point it will give me maximum or the minimum. So whenever you come across the smallest or the maximum elements, and when he has given the k, any value k, so you need to think about priority queue. Now let's see how priority can optimize my problem. Now if you see these elements, so my priority queue, it will give, after pushing this into the priority queue, suppose we are pushing 2, 11, 10, 1 comma 3. I will be using the min heap. I will be using the min heap. So if you are not aware of the min heap, go and search it, and it's like a pretty good concept. It will be like there is a good implementation of the priority queue. You can understand that, but in C++ we have priority queue as a standard library, so we can use that. Now in priority queue, first step it will give the two minimums in log n time. It was given log n time. Now first I will take the two minimums 3 and 2. I will perform the operations. I will get 4 and I will push into the priority queue. Then in the second step it will take the two minimums and it will produce some x, and it will be 11 10x, and then it will take the two minimums. If my top minimum is greater than or equals to k, I will stop there. So I think you have got it. So why we are using the priority queue? Because we want the minimum at every point. You can use sorting, but after insert you need to delete it, and you need to add the element, and you need to sort the whole array. So that is like a costly operations, we can say, and costly, and it is similar to n into n only. Now let's understand. So I think you have got the logic. So try search in Google what is a priority queue, then give it a try. So I think you have tried for a couple of minutes. You try to code it. Now let's understand the coding part. Now here we are using the priority queue, where this is my variable. So every element I am pushing into the priority queue. and my q dot size greater than or equals to 2. Greater than 2 only I can perform, right? So is in this question he has maintained, he told that if nums contain at least two elements, then only you can perform this operation. So I will iterate till my greater than or equals to 2, and I will check whether my q dot top is greater than or equals to k. If it is greater than or equals to k, my minimum element is greater than or equals to k, that means all other elements in the priority queue will be greater than or equals to k. At this point I will return my c, or else I will calculate q dot top, and I will push my new element. After performing these operations, I will push the new modified element into the priority queue, and I will incrementing the counter, and finally I am returning the counter. So it will not go till here, but it's like, because in this you can see in the constraints the input is generated such that answer always exists. So definitely my answer will be there will be some sequence which is greater than or equals to k. So here you can see the time complexity will be, it will be log of n into log of n. It will be n into log of n. So I think you have got it, and you have got to know about the new concept. So if you think you have learned something from this video, please do consider to like, and please subscribe to my channel. And if you are interested in this DSA discussions, I have created a WhatsApp community, Code with Confidence. You can join that. The link is provided in the description. So I will see you in the next video. Till then, bye bye.